And we noticed, just even though it wasn't a randomized trial, that when we laid the two case series against one another in a retrospective case series, that the trajectories of improvement were identical for these two things. And it was at that point that I spoke with Jeff Daskalakis and Dan Bloomberger and Fidel Villa-Rodriguez over at UBC and said, well, maybe we should do this properly as a formal trial, because cutting the treatment time down to 3 minutes means it's only about 100 minutes of chair time, which is a lot better than 22 hours of chair time. And
Sure.
This could just generally make TMS faster and cheaper and better for everybody. Oh, interesting. Yeah. So that's the other neat thing that cycloserine seems to be doing. The 12, and this is in the preprint, the 12-week numbers are great. In fact, a lot of people are doing better at 12 weeks than they were at 6 weeks. If you look at all the individual curves, we had a couple of people relapsing after 6 weeks and starting a slide again at 12 weeks, but the vast majority of people are doing as well or better by 12 weeks than they're doing at 6 weeks. I do think it may be reasonable to say that if you do this recipe, that whatever clinic you operate at, whatever remission and response rates you're used to seeing in your clinic, they're not going to be worse on the one-day protocol than they were for a conventional treatment. Will they be better? Hopefully, but they're not going to be worse. These numbers were certainly better than the clinics we drew the patients from are used to seeing.
Welcome to Stimulating Brains.
Hello and welcome back to another episode of Stimulating Brains, the podcast where we explore the latest advancements in brain stimulation, neuromodulation, and the people driving innovation in this space. Today we have a truly fascinating guest, Dr. Jonathan Downar. Jonathan is a psychiatrist and neuroscientist based in Toronto, where he leads cutting-edge research on transcranial magnetic stimulation for depression. Many of you know him from his landmark work on the 3D trial, which helped establish theta-burst stimulation, iTBS, as a rapid, effective alternative to standard repetitive TMS. More recently, he has been pioneering accelerated TMS protocols, including the 1D study, which tested whether an entire TMS course could be condensed into a single-day treatment regimen. In today's conversation, we'll talk about his scientific journey, the future of brain stimulation, and what it means to approach TMS innovation in SpaceX mode, as Jonathan puts it. We'll also discuss his bold vision of 1 billion depression patient remissions in our lifetime. So without further ado, let's dive into the conversation with Dr. Jonathan Downar. Thank you for tuning in Stimulating Brains. So, Jonathan, thank you so much for joining us and making time to do this. Off your busy schedule, by now we'll have introduced you more formally so we can dive right in. And I always ask an icebreaker question first. So when you get a moment of free time, what do you do?
Oh, thanks so much, Andy. It's great to see you. So thanks for having me on the podcast. It's a pleasure to be here and a pleasure to see you again. All right. So what do I do when I get a moment of free time? I am a new father as of about a year and a half ago. So I've got a 16-month-old boy. And at the moment, when I do have free time, I try to spend some time with him. He's at that inquisitive, exploring age. So we sort of wander around the grass in the yard and look at things and pick things up and all that.
Beautiful. Great. Any hobbies you had before the kid?
So I've always been pretty keen on kiteboarding. And so, it seems to be a bit of a thing in the TMS community. So I have a couple of kiteboarding friends. Nolan Williams, for example, would be a guy I've gone kiteboarding with once or twice. I will confess I have not been out on the water for at least 2 years. But it is if I ever get out from under all this stuff, it would be nice to get back out there again. And hopefully some of my other TMS colleagues can come out and we can have a nice little session on the water someday.
Sounds great. Cool. Okay, so diving into your career and scientific journey, what originally drew you to the field of neurostimulation and maybe depression treatment?
Okay, that's a great background question. So, I guess I originally came to medicine from a neuroimaging background. I did my PhD in functional MRI starting in 1998 when the technology was still fairly new. And so, when I trained in medicine and then in psychiatry, I think the idea was to try and use neuroimaging to do something useful for psychiatry. The dilemma was that after 4.5 years of residency, I couldn't figure out exactly what to do with it because neuroanatomy or neuroimaging was really great at delineating, the functional neuroanatomy of emotion regulation and social cognition and decision making. And so we knew where all these circuits were thanks to a bunch of neuroimaging. But then the question is, what do you do with that with conventional psychiatry? Because you can't tell Prozac to just go to the right orbital frontal cortex, or you can't tell therapy to just work on this particular network or whatever. So and so I was struggling to try and figure out what to do with functional neuroimaging and how to integrate that with psychiatry. And at some point, it occurred to me that because functional neuroimaging was neuroanatomically specific in its findings, that it needed to be paired with an intervention that was neuroanatomically specific, more so than things like ECT and so on. TMS was the up-and-coming technology, which I guess as of 2009 was sort of underperforming. I think people were a little underwhelmed by TMS. It was at the bottom of the hype cycle at that time. But I formed the impression that maybe we weren't putting the coil in quite the right place, and maybe we could treat a wider range of things more successfully if we started to integrate some neuroanatomical knowledge into it. And so that's where the shift to TMS came from. And so I had a few conversations with Jeff Daskalakis about who was the local TMS luminary at the University of Toronto. He gave me a few pointers on how to get started, and went out and raised some money and bought a device and started a TMS clinic and started treating patients.
Super cool. And then who were your mentors and also major influences or turning points in your career?
Yeah, so I think so. Who were the major mentors then? I think first of all, my PhD supervisor, Dr. Karen Davis, who was gracious enough to allow me to take this new technology of functional MRI as a young master's student and just try things with it. So she was willing to kind of give me a little bit of freedom to explore things like consciousness and salience rather than the areas within her lab. A second one, I think a mentor and also a friend, my friend David Eagleman, who I ended up writing a textbook with on cognitive neuroscience. David's a friend, and he and I have written a book together, but really also very much an inspiration as a person who managed to put together a very kind of impressive artistic career alongside his scientific career, and a real polymath. So very much an inspiration there. And then the third person I think I should really call out would be Jeff Daskalakis himself, who's always been a great friend and mentor and been there for me at all the good times in the career and the tough points, and both as a friend and as a scientific mentor. So all three of those people have been definitely deserve a shout out.
Super cool. Was there any pivotal moment or turning point or anything that shaped where you are now?
I think that was in terms of turning the brain imaging into pairing it with neurostimulation. I think it was after a few conversations with David and with Jeff about what we might be able to do with TMS if we could get the anatomy nailed down. I think that really is what propelled me towards the current direction. Other influences just in the general background, I think I have been influenced a little bit by the Silicon Valley influence and by the examples of Tesla and SpaceX. I'll say I've never met Elon Musk. I've never worked at any of those companies. But what I was attracted to, particularly at SpaceX, was their idea of just trying to generally massively improve the economics and scalability of putting stuff in space. So, from 2016, when I think I can remember quite clearly first seeing them land for the first time a rocket ship on a barge, and it really wowed a lot of people. And so I dug into the company a little bit more and tried to figure out what they were doing. And it was interesting that they were looking at just radical ways to change the way spaceflight was done and just ask different questions to try and figure out how to reduce the cost of putting stuff into orbit by 100 times. And so, it ends up being that something like whether you can reuse the rocket or not, which no one really thought was an important question, turned out to be a critical question for being able to put lots of stuff in space. And so by reading them and thinking about them, I think I can definitely say that applying some of that it got me thinking about applying some of that same type of philosophy to TMS. And were there ways that we could make TMS 10 times faster? Could we make the learning curve 10 times easier? Could we make the cost of TMS the same as medication? And what would that take? And what questions do we need to be working on? And that definitely steered the whole lab in different directions. We'd originally been focused more on neuroimaging and biomarkers and things like that. And now we realized that a lot of these questions are just about scalability, about changing the hardware around, and about trying to make the protocols more efficient and requiring less time in the chair and less complexity. So constantly focusing on simplicity and scalability, and is there a way we can get this down to the ease of use and complexity and convenience of medications, and the cost of medications, at which point we could potentially take this great treatment and scale it out to millions and maybe 1 billion people over time.
Yeah, and I think that also led to less time spent in the chair. I think was also, or might have been, behind your 3D trial, and maybe also feel ad lib to tell us a bit more about the history of TMS. I'm not an expert. I'm more a DBS person, as you know. But my understanding is that the 3D trial was that you last authored in 2017, was published in The Lancet, was a landmark trial for the reason that it essentially put iTBS on the map, or showed that iTBS was non-inferior to conventional 10 Hertz rTMS treatment. Can you maybe, for the naive listeners, first describe what these two options are and what you showed there?
Sure. Let me embed this in a little bit of history. So one of the things I love about TMS in general, it's unlike pharmacology. Once you've discovered a molecule like, say, S-ketamine, it's still going to be the same S-ketamine 20 years from now. Fluoxetine, Prozac is still the same fluoxetine it was in the 1980s. But technologies are different. If you bought an electric car in 1995, it was probably pretty terrible. And now here we are 30 years later, and they're quite a lot better. Wind turbines didn't used to be economical ways of generating power, nor did solar panels. But all of a sudden, with the technology, you can keep chipping away at it and making it faster, cheaper, and better, and faster and cheaper and better. And if you look at TMS, that's exactly what happened. So a very, very compressed history of TMS. 1985, Tony Barker first invents and demonstrates the technology. Published in May 11th, 1985 in Lancet was the first report of this device for transcranially magnetically stimulating the motor cortex. Fast forward 10 years to 1995, 1996, and Mark George in one paper and Alvaro Pasquale-Leone in another paper demonstrated in patients that this could actually have antidepressant properties if you place it over the left dorsolateral prefrontal cortex. Fast forward another 10 years, people did lots of various trials. But by 2007, John O'Riordan and colleagues ended up, and then Mark George in 2010 did a pair of trials showing that TMS in two large groups did better than sham. One was an industry-sponsored trial, the other was NIH-sponsored. So we had FDA approval in the United States for TMS for depression as of 2008. And fast forward another 10 years, and we get to the 3D trial. So at the time of the 3D trial, the standard John O'Riordan or FDA-cleared protocol involved 3,000 pulses of 10 Hertz stimulation delivered over a period of 37.5 minutes. Now, that's great and all, but a standard course of TMS in the United States is 36 sessions. And so if you do a little bit of math, you're looking at about 22 hours of chair time to treat a patient. So when we look at 22 hours of chair time, it's just not easy to imagine how 22 hours of use of a specialized room, a specialized technician, specialized equipment is really going to scale to millions and millions of people. We ran into this firsthand in Toronto when we opened our doors. The Toronto clinic that we opened in 2010 was always a free clinic. We always let anybody come in, never charged anybody for it. And the problem with that is eventually people found out. And so lots of people started to show up and come in for TMS. And very quickly, our one machine was overwhelmed because you only get about 8 or 9, maybe 10 sessions a day if you work really efficiently. And so you can only treat one new patient every 3 days. If you start getting a referral a day or 2 referrals a day, there's no way to keep up. So we bought a second machine, and then we kept up for another 6 months. And then we realized we weren't keeping up, and we just start trying to raise money for a third machine, and that wasn't going very well. And so we started getting the big lineup. And at that time, we were aware that there was this faster protocol called theta-burst, which was supposed to be able to use patterns mimicking the theta rhythms of the brain. The original impetus for that was from work on long-term potentiation and long-term depression in hippocampal slices, where they noticed that the hippocampus generates these little bursts at theta frequencies, which seem to be, at least in the dish, were more efficient at inducing plasticity. So out of John Rothwell's lab in 2005, Huang and colleagues did a very now very well-cited study in neurons showing that you could sort of mimic the theta-burst approach in motor cortex with a TMS coil. And now you were getting significant plasticity in 1 minute for the inhibitory version called CTBS and 3 minutes for the excitatory version called iTBS. So just as a measure of dealing with our wait list, we started, and we're saying even if it's not better at inducing plasticity, even if it were just about the same, this could potentially help to cut our wait list down and get more people in. So we started treating a whole bunch of people using the 3 minute theta burst treatments. And by 2015, we treated about 185 patients, some on 10 hertz and some on 3 minutes using, this was at a dorsomedial target, which we favored at the time. And we noticed, just even though it wasn't a randomized trial, that when we laid the two case series against one another in a retrospective case series, that the trajectories of improvement were identical for these two things. And it was at that point that I spoke with Jeff Daskalakis and Dan Bloomberger and Fidel Villa-Rodriguez over at UBC and said, well, maybe we should do this properly as a formal trial, because cutting the treatment time down to 3 minutes means it's only about 100 minutes of chair time, which is a lot better than 22 hours of chair time. And
Sure.
This could just generally make TMS faster and cheaper and better for everybody. So the concept was born of, let's do 3 minutes versus the standard 37 minutes in a non-inferiority study. Non-inferiority studies require a lot of patience. So this was, unfortunately, Dan Bloomberger is a consummate trialist who is phenomenal at designing and executing and quality control and making sure. So he really dove into, communicating with the FDA and making sure that the data was going to be collected in a way that was, compatible with. So our 3 clinics plugged away for between September 2013 and I guess around the spring of 2016, this plugged on for quite a long time, and maybe heading into late 2016, we plugged away until we had about 400 patients. So I think it's still one of the biggest trials done so far in the brain simulation world in general. Not because we were trying to show off, just because you just need a lot of statistical power to do a non-inferiority study. But fortunately, the results were very clear that just as we'd seen for dorsomedial, the 3 minute treatments also work well for dorsolateral. There are 2 neat things about that study. First of all, the FDA, thanks to Dan's hard work in preparing all of this, the FDA followed through with a 510K clearance for just later on that year. And so the theta burst treatment got very widely adopted even a year later at the Clinical TMS Society. It's an informal poll of the audience showed that a majority of people were already integrating 3 minute theta burst treatments into their clinic. So that was exciting. We were hoping that this would reduce the cost of TMS down to a point that the Canadian government and the various health agencies there would decide to adopt it, and the TMS would be rolled out more quickly. Unfortunately, it didn't translate immediately into a Canadian rollout, but certainly in the US, I think TMS started to take off and expand a little more quickly. The third thing that was neat to call out about this is we realized that this project had actually managed to create a new FDA indication, or at least a new FDA indicated treatment, for a cost of under $3 million in a timeline of maybe 4 or 5 years. That's really exciting when you compare that to pharma, because as we know, there are still lots of great pharma molecules being generated, but it seems like they cost more and more every year to find, and it takes more and more time to find them and to prove them out. And so it's not uncommon to see $2 billion in 20 years of development time to bring a molecule to market. And so, if you imagine that you had some new technology like, deep pharma or something, like some AI that could somehow reduce the pharma discovery timeline to 2 or 3 years and reduce the cost from 2 billion down to 2 million, that would be a pretty exciting technological development. Yeah. Well, if you cross out the word AI and you write in the word TMS, that's sort of what we have. So I do like to encourage people to think of the possibility of TMS as this phenomenal technology that allows us to radically compress the discovery pipeline for new treatments for things that TMS works for, not just depression, but we have great studies in Parkinson's and Alzheimer's and anxiety and post-traumatic stress disorder and bipolar disorder and lots of things, and chronic pain and lots of things that are, not approved in every jurisdiction, but easily could be with a pivotal trial. The cost of doing those pivotal trials in TMS world is low enough that even 3 little labs or 3 little clinics can get together and plug away at this for a couple of years and do what would normally take a gigantic pharma company a lot of time to do. So I think that's one underappreciated thing about the excitement of TMS world, is that it's possible to get completely new indications proven out all the way to FDA on budgets that are tractable even for humble researchers rather than gigantic pharma companies.
Super interesting thought. Never thought of that. That makes a lot of sense. And you already spoke about how iTBS has, since your trial and since the FDA approval, impacted clinical practice. And I think by now we could say it's standard, or now maybe replaced by the next thing that happened, which was probably the Saint.
That's exactly right. So. Yeah, that's exactly. So I think we were going through the timeline of great moments in the history of TMS, all the way from 1995 invention, 1995 first pilots in depression, 2007, 2008 FDA approval, and then 2018 getting the treatments 10 times faster, so an order of magnitude improvement in the chair time. And then along comes the group out of Stanford, Nolan Williams' group, who, again, a dear friend and colleague and a very bright original thinker, a first principles thinker, very much along the SpaceX line, thinking about ways to achieve further 10x improvements in things. And the 10x in this case was, why are we doing it just once a day? Why are we waiting 24 hours between sessions? Could we just do 10 sessions a day? There was a study as early as 2010 where Paul Holzheimer and colleagues had experimented with doing up to 10 sessions a day in a highly accelerated form, and it looked fairly promising. I'll come back to that later on. But Nolan's idea, among other things, was to increase the number of pulses, so doing kind of 3 theta bursts on every session, but then do that every hour, 10 times a day, and deliver a total of 50 sessions. And then not so getting the whole thing done in 5 days by doing 10 times as many sessions per day. And not merely stopping there, but then in addition to that, being a lot more rigorous about where you put the coil by doing neuroimaging to try and pinpoint an area that lies on the network anti-correlated to the subgenual, which, as you're well aware, is the DBS target that's often used in depression. Yeah. So non-invasively stimulating the same network that you would do invasively through DBS and personalizing that to each person. And then coming away with that, showing that, wow, you can indeed get people better with a 5-day course of TMS, which is in itself a job quite a showstopper. But then on top of that, reporting very high remission rates and attributing those to the personalized targeting rather than just a generic target. So 2 big claims there, which either one of which would have been very impressive in its own right. First of all, a very high remission rate, and then second of all, a very rapid onset of effect. Either one of those claims all by itself would be great, but getting 2 of them together in one protocol certainly constituted a breakthrough. And so when Saint got FDA clearance in 2022, then that was, again, a major breakthrough.
Yeah, and we had Nolan on the show as well. We also had Mike Fox on the show, who was, I think, instrumental in thinking about this anti-correlations with the subgenual. And yep. if I had to ask you, I think nobody really knows the answer to the question, but which of the 2 components, more pulses or better targeting, was more critical? What do you think?
So I think there's going to be contributions from both. I think it's an empirical question. I think it also depends on what you're looking at. So we'll come to this when we talk about the 1-day protocol that we've put together. So certainly doing more, I think if you're going to improve the outcomes of TMS, one of the, across the entire literature, doing more sessions is always helpful. And then, so adding more sessions, certainly going from 30 sessions up to 50 sessions generates benefits for some patients, and some people have tried even longer courses. In fact, Nolan treated a relative of a friend of mine who didn't respond to 36 sessions, but because Nolan was really persistent and was really advocated for this patient, that person was able to get a second course of 36 and ended up going through a very sustained remission, and has stayed in remission ever since. So really meaningful impact there. So, certainly adding on more sessions is very valuable. The role of how many pulses constitutes a session, that's the big fuzzy question. We don't think it scales linearly. So there is some minimum number of pulses you need to induce. And we know that from Paul Fitzgerald's work in Australia that whether you do on 1 hertz, for example, whether you do 3,600 pulses or 1,200 pulses, you get the same outcome. And 3,000 versus 5,000 pulses at 10 hertz seems not to make that much difference. In the realm of theta-burst, it's there's different opinions on whether 600 pulses does the same as 1,800 pulses or whether you need to do the full 1,800. But I would say certainly I think most of us are agreed that more sessions is good, and that there is some minimum amount of pulses that counts as a session, and we're still trying to figure out what that minimum is. Obviously, in the 3D study, it looked like 600 pulses did pretty well, and in the 1D study as well, 600 pulses seems to be doing quite a lot for people.
Super cool. And so when Nolan told me that he was also a bit inspired by deep brain simulation, which obviously fires 130 hertz, 130 times per second throughout the entire day, right? So I think that was one idea of like there's just not enough pulses for a great effect. Did that same thought ever influence you too? Like, was that an inspiration, or was it not really?
Yeah, it's interesting to think about that. I think there's certainly. It's an empirical question that I think we'll sort out over time. Adding more pulses in the form of more sessions certainly seems to have been very effective in pumping up the remission rates in SAINT. And I think even if you just do 50 sessions, even on a 1-day schedule, you will definitely get a better remission rate than if you do 30 sessions. Yeah. I think an important distinction between the time course of DBS and the time course of TMS is that, and we'll have to think about, this is maybe a nice topic to have between the neurosurgeons and the non-invasive people. I think neurosurgery has been very influential upon TMS in terms of specifying where we should be putting the coil and what networks we should be thinking about. But what's interesting about TMS is that people don't walk around with the TMS coil on their head all day long the way they do with a deep brain simulator. And so the cool thing about TMS is that the neuroplasticity is engaged. So even though you're not doing anywhere near as many pulses as you are with DBS, and then even though you stop after a certain number of days, the effects continue to endure for weeks and weeks and weeks. And so I think it might be interesting for all of the invasive modalities like vagus nerve stimulation and deep brain simulation. What if and I think people are already starting to look at this, what if we try to learn from / copy from / adopt some of the more TMS-like protocols into our invasive brain simulation? At the very least, we could save on a bunch of battery life, and maybe we wouldn't have to do quite as much stimulation quite as much of the time. So, and potentially we could even get a more rapid onset of effect. So I think it'll be interesting to see what happens in the deep brain simulation world when we maybe go down to fewer pulses, but pattern them in ways that seem to induce plasticity with the way that TMS does. Maybe you've done some of that work already. I know some people are interested in that question. So
no, super cool thought, and I'm not aware of studies like that. There are multiple indications such as stroke or so that have started to do a non-100 above, like non-high frequency DBS but low frequency DBS, but I think these more pattern simulations are not really happening. I think people are thinking about it a lot, and there might be some studies where with an externalized lead or so, people are trying to do things in the lab setting, but I'm not aware of like big scale indications so far. But it's a great thought. So to be inspired from TMS.
So let me unpack that a little bit further as well, because we know in DBS, anyone who's been around DBS patients sees that you can make an implantation, and you can even do some, even during the operative procedure itself, you'll often see some dramatic transient improvements in the symptoms, but then you also have these trials that have failed to show a big benefit in the two different groups, and it's not. We've always assumed that that's because the coil's not in the right place, or rather that the electrodes aren't maybe quite in the right pathways and so on. But it's important to remember that there's also the question of whether plasticity is being induced, and whether you're favoring LTP or LTD, or whether you're just stepping on both the accelerator and brake at the same time. So I think when we think about the so-called failed trials where we're not seeing a difference between the active and sham stimulation, we should think about the location of implantation, the anatomy, but we should also be thinking about, is it advisable to just be running continuous tonic stimulation in there all the time? Is that possibly why some people don't respond? And if we were to switch to something more like a Saint-like protocol where it reports these much higher remission rates, could we get some people to respond to DBS not by moving the electrode at all, but simply by just patterning the pulses so that they're more likely to induce plasticity rather than just jamming the network? So so I do think it may behoove us to think about that, because and this comes up in TMS as well. Certainly for TMS, when we look at the mechanism of it, part of the mechanism involves neuroanatomy, but part of the mechanism involves neuroplasticity. And when we find non-responders, some portion of non-response is due to off-target coil placement, but we're also learning through the 3D study, which I guess we'll be talking about shortly, that also a fairly large portion potentially of response is due to not enough plasticity. And that if we can remedy that in various ways, that we can turn a lot of non-responders into responders without having to move the stimulator around.
Yeah, I love the thought. It's very interesting. I mean, we should emphasize that, for depression, we are in essentially anti-correlated networks. So in DBS, I think the idea is still to downregulate something that's overactive, while maybe, in simple terms, right? So it might also then, in that case, require a shift of where to put the electrode into the more anti-correlated network in a way. But I love the thought. So let's talk about your 1D trial, which is, I think, the most exciting thing that has happened to TMS since Saint. It is currently a preprint. Do you want to briefly summarize it? I think the idea was to even further condense and do a one single day treatment over 10 hours, if I remember correctly.
Yeah.
So let's talk about the
genesis of 1D, very much like the genesis of 3D, came from the patients. 3D was just was a response to the fact that we thought that what we were supposed to be doing was using MRIs to personalize all the treatments. And what I found is none of the patients were complaining about the remission rate. They were complaining about how long it took to get in. So that's why we decided, well, why don't we at least have a project that addresses that? And getting then the other thing, of course, that patients complain about, or that they say, I can't come for TMS, even though it might be good for me because I can't find 36 days in my schedule. Okay, great. Well, now we have these 5-day protocols. So all you need to do is take 5 days off. And you still have some patients, a fair number of patients say, look, I live 4 hours away and I have responsibilities. I could come for 1 day. I can't come for 5 days. So do I need all 5 days, or could I just come for, 2 days or 1 day? And we got to thinking about that, and I realized I actually didn't have any numbers that I could give to a patient about what that would do. So if a patient asked me, well, if I could only come for 1 day, what are my odds? And the only thing I could draw upon was Paul Holzheimer's paper back from 2010, when he was literally the only person who, back in 2010, it was one of the very first reports on accelerating, possibly the first report of doing 10 sessions on day 1 and then 5 sessions on day 2 and then sending them home. So 15 sessions produced a pretty respectable 29% remission rate and 43% response rate, which is, for those days using those protocols was pretty similar to what you get with a normal course of TMS in those days. And because I remember reading that paper in 2010 and thinking, we should do some of this accelerated stuff. And then just bizarrely, the field just didn't do very much with it. Like some people tried 3 sessions or 4 sessions or 5 sessions, times 1 or 2 or 3 days. But nobody ever went back and tried the 1 day, they were 1.5 days or 1 day. So it's never been replicated. So we realized that we probably should at least, because there were plenty of patients who said I can come for 1 day. So what does 1 day do for me? So we said, let's actually ask that as an open question. We have these patients who are not willing to come for 5 days, but they are willing to come for 1 day. And we don't know what that'll do for them. So if they're willing to come and try this out, let's at least do everything we can think of to make that 1 day as impactful as possible. And so the first thing we could do is reduce the interval a little bit. So traditionally, a 60-minute interval has been respected in the Saint protocol and many other accelerated protocols. For reasons due partly to Charlotte Netkoven's paper in motor cortex, they were seeing that you could do sessions 30 minutes apart and getting an additional bump of plasticity. And then Andre Brunoni also recently had a study out in which he was able to do a semi-accelerated 3 times daily treatment with a 30-minute interval and seeing good effects there. So let's try and squeeze in more sessions. Let's do a 30-minute interval and see what that does. let's also offer 3-minute 600 pulse theta burst because, from the 3D study, we seem to think that's useful. So now we've got 20 sessions in 10 hours. And the only problem is that 20 sessions isn't really enough to get that many people to remission. When we know from our trajectories analyses of the 3D data that there are people who are all the way better after that few sessions, but those fast responders who have lots of plasticity, they're a minority of the sample. They're only about 20% of the sample. On the other hand, there are other groups, which I'll come to in a second. There are slow, medium, and fast responders. So 20% of people are fast responders. And so if we just do 20 sessions, even if the acceleration worked, we should only expect about a 20% remission rate. And in fact, but what else could we do for them? Well, we happen to have what I think will end up being a seminal paper in the field, or in retrospect will be a very influential paper in the field. Alex McGear's group in the University of Calgary in 2022 published in JAMA Psychiatry on the effects of adding the NMDA partial agonist D-cycloserine onto a rather stingy 20 session course of TMS. I say stingy because in Canada, sometimes that's sort of what we do for people, but a 20 session course is less than what you would normally do in the US. And a lot of people would say it's like not enough to get most people to response. And in his 2-arm study, his placebo DCS group, who got 20 days of 3-minute theta burst once daily, they only did just under 20% of the people remitted in that group. But by adding on D-cycloserine doses 1 hour before each day of treatment, interestingly, the remission rate doubled to 40%. And what was exciting about that was they actually only gave the D-cycloserine for the first 10 out of those 20 days, suggesting that if you did them for all 20, could their rate be even higher? So, the other problem is that's a lot of D-cycloserine. It's a hard medication to obtain in Canada, and it's fairly expensive even in the US. So, one advantage of doing all the sessions in a single day is you can just use a single dose of D-cycloserine. So the core of the 1D protocol is really to do 3 minutes of stimulation 20 times per day, and we will add on D-cycloserine. And we were hoping that we'd get a remission rate somewhere between 20% and 40%, since that's what Alex saw in his story in studies, and that would indicate that, we could take the 20 sessions. You'll see in a moment that that's not quite what happened. What happened was substantially better than what we expected, but we were expecting a remission rate somewhere between 20 and 40%. And then we would go back and do a 2-day version, and then a 3-day version, and then a 4-day version, and we'd just figure out what the distribution was. At least that was the plan. One final thing we did, which I'll emphasize, I don't think anymore that we have to do this. So I hope people who in the future try this will drop this from it. We also added on the stimulant Vyvanse, lisdexamfetamine, at a low dose of 20 milligrams because of results out of the UCLA group. Andy Luchter's group ended up doing a study where they found that psychostimulants like lisdexamfetamine or dextroamphetamine or even methylphenidate would speed up people's response to TMS. And modafinil, interestingly, didn't. So it looked like it had to be a dopaminergic mechanism. So just because we were trying to get the most bang for the buck, we added in Vyvanse. We've since gone back and done another series not published yet where we don't use the Vyvanse, and the outcomes look very similar. So there's one take home is if you are going to go out and try this at some point, I don't think the Vyvanse is as necessary as we thought it would. But nonetheless, in the preprint, patients would come in. These were regular TMS patients from regular community clinics. These were very kind of run-of-the-mill TMS patients. The only thing was that their insurance, for some reason, had denied them, or they just said that they couldn't come in for 36 sessions. And so we went through and we gave them these 20 sessions in a single day. 1 hour beforehand, they got 125 milligrams of D-cycloserine as well as 20 milligrams of Vyvanse. And then we performed a baseline Hamilton depression rating scale, Beck Depression Inventory, GAD-7, and PHQ-9. And because in previous accelerated studies, it appeared that, including the SAINT study, they would follow people out for 4 weeks afterwards because some people would respond later than the initial treatment. We decided to follow people out for 6 weeks after the treatment, just in case some people didn't respond right away. That turned out to be a really good idea because, in fact, almost nobody responded right away. It was not like ketamine. And if we followed people 1 week after. And so what happened is we then started looking at what people were like 1 week after treatment. And sure enough, 1 week after treatment, about 20% of people were in remission. And we're like, all right, well, that's sort of what we were expecting. But then 2 weeks later, suddenly 40% of them were in remission. Oh, okay, well, this is sort of like, the upper end of the curve. That's great. Then it was 3 weeks. 3 weeks, 60% of them were in remission. And it's all right, well, okay, something interesting is happening here. And then at 4 weeks, it was closer to 70%. And we ended up plateauing out across almost all the measures. You got about a very consistent 80% improvement in symptoms from baseline. So depending on the scale, most scales were a little above 70% remission across all 4 scales, and at least 90% of patients showing greater than 50% improvement.
Really fantastic.
Bit of a jaw dropper to see. But what's interesting is we then look back at our so 2 unexpected findings. First of all, well, 3 really. First of all, and I think the only real take home I think I feel comfortable saying is, it looks like doing all the sessions in 1 day with neuroplasticity agent. If you do that, I'm not claiming that every clinic in the world and every clinic with tough populations and VA and homeless patients and so on is going to get a 90% response rate. I don't think that's reasonable to claim. I do think it may be reasonable to say that if you do this recipe, that whatever clinic you operate at, whatever remission response rates you're used to seeing in your clinic, they're not going to be worse on the 1 day protocol than they were for a conventional treatment. Will they be better? Hopefully, but they're not going to be worse. These numbers were certainly better than the clinics we drew the patients from are used to seeing. The second part is that people don't get, as you said, people don't get better right away. So unlike in SAINT, where the personalized targeting potentially is causing this phenomenal outcome where people are often better by the third, not even before the end of the week, by the third or fourth day, they're already showing a sudden flip in their mood. You're not seeing that on the 1D protocol, which doesn't use personalized targeting. What you're seeing is this: you put all the sessions in, but then interestingly, it still takes between 1 to 6 weeks for the people to actually show the full response and remission. And sure enough, you have fast responders and medium responders and slow responders, just like you do in the 3D trial. The difference is that almost all of them go to remission, because I guess with the enhanced plasticity, what that suggests is that by enhancing the plasticity, what you're doing is you're taking your slow and medium responders and you're turning them into faster responders, and you're also getting them all the way to the remission line. The only people who don't come along for the ride are the non-responders. In the 3D study, of the 4 trajectories of response, there is one true non-response trajectory where they don't show any improvement. They're just completely flat. Most people show a little bit of improvement, but the true non-responders show a completely flat, no improvement whatsoever. What's interesting about them is they're actually only 10 or 12% of the sample, which is the same as what we saw in the 1D study. So it actually suggests that really we could be looking at a very similar thing where we have about 10 to 15% of people who don't respond. And likewise in the SAINT trials as well, there are this sort of hardcore about 10 or 15% of people who don't respond and everybody else does well. And in 3D, there was a hardcore 10% of people who didn't respond at all. And then everybody else responded weakly or moderately or strongly. And then in the 1D study, we have 10% of people who don't respond at all. And then everybody else gets better, whether it takes them 1 week, 2 weeks, 3 weeks, or 4 weeks, everyone else eventually gradually gets better.
What I like about the delayed response is that it's also a bit, it doesn't smell like placebo at all, right? Or would a typical placebo curve also be as delayed?
That's why we think this might it overturns a lot of our assumptions about how TMS works, because you're absolutely right. The timeline of the intervention is completely uncorrelated with the timeline of the improvement. And just to clarify, because I've had people ask me this, these patients did not get anything after the 1 day. There was no more. So they don't get D-cycloserine or Vyvanse every day, just on the day of treatment. Yeah. And they only get TMS on the day of treatment. They don't get any follow-up except for remote calls for the Hamiltons and just an annoying email to send in their PHQ-9s and other questionnaires. So they're not getting any of the stuff that a regular TMS patient gets. We've always assumed in TMS that a fair amount of the response is the non-specific factors, the stuff other than the pulses. If you sign up for 36 days of TMS, every day you're going to get up at a certain time. You have behavioral activation. You're getting out of the house. You have social interaction. You're sitting in a chair getting therapeutic contact. You have schedule. You have routine. You have purpose. You have all this stuff. These patients have none of that. They just got one day and then they get sent home, and that's it. And bizarrely, without any of those things being present, they still, almost all of them got better, and it developed over time. So you're right. It's the timeline of improvement does not track the timeline of the non-specific parts of TMS, which argues against a placebo response, and which is why I'm very excited to see what kind of placebo, how this turns out in a placebo-controlled trial. And I do know that, quite aside from our group, other groups in Europe and elsewhere are already spooling up some placebo-controlled trials to give this a shot.
Yeah, sure. So I'm sure. Do you have any like unofficial things you can tell about, for example, how long did it last in some, and then also did you try without the D-cycloserine ever?
Yeah. Okay, so now we're getting beyond. So bearing in mind that this is none of this is peer reviewed yet. So even 1D is just a preprint; it hasn't been peer reviewed yet. And then we have new cohorts who we're running since then. We have a cohort that we've run without the Vyvanse, just with the D-cycloserine. It's early days yet. I don't have them followed all the way through, but they look like they're doing fairly comparably. And so I think there's an argument that if you're in a jurisdiction where Vyvanse is complicated or you're concerned about using the stimulant, just don't use the stimulant. I mean, it is only one day of stimulant, but still, if it's complicated for you, I don't think it's silly. Alex McGeer, for example, did not use any stimulant whatsoever. In his studies, he's only used D-cycloserine and is seeing this tremendous boost without any recourse to use stimulants at all.
I understood that, but did you also try without the D-cycloserine at all informally?
We have not tried it without the D-cycloserine. It's an interesting. Actually, someone suggested to me that Saint in some ways might be an example of what, or rather Saint without the personalized targeting. So if you were to look at outcomes of people doing Saint without the personalized targeting, that might not be a terrible proxy for what happens without the D-cycloserine, in the sense that, I mean, there are folks out there who are doing 40-session protocols over 5 days. And I don't believe that, at least from the published results so far on that, doing 40 sessions over 5 days, which is twice as many sessions without D-cycloserine, I don't believe we're seeing the same kind of response and remission rates from those kind of outcomes there. So we haven't personally done it, but there is data out there suggesting that the D-cycloserine may be an important ingredient. Alex McGeer's sham-controlled trial, again, suggests that DCS is an important ingredient, but we will have to wait for a sham-controlled trial to see how important it is. The other thing that I'll indicate is, what's the other thing we're doing right now? We're also trying D-serine at the moment rather than D-cycloserine. D-serine is and this is after a conversation with Josh Brown and Carrie Ressler over at McLean Hospital. So they're quite up on the various molecules that can be used as partial agonists of NMDA. D-serine is interesting, and sarcosine is interesting, because they both work on that system, and neither one is even a prescription medication. They're substances that are found in low quantities naturally in the body, and so they're actually classified as nutritional supplements. They're a lot cheaper, they're a lot easier to get, and they're very scalable. So it would be of high interest to determine whether D-cycloserine is necessary as an expensive, hard-to-get medication, or whether we can accomplish the same thing with D-serine, which is, again, just falls under the supplement category. We've just started running that this week, and I'm hoping that in about 2 months from now, we'll have a sense of what the D-serine is doing.
Okay. And then any gut feeling that there's more relapse after 1D than the normal?
Oh, interesting. So that's the other neat thing the D-cycloserine seems to be doing. The 12, and this is in the preprint, the 12-week numbers are great. In fact, a lot of people are doing better at 12 weeks than they were at 6 weeks. If you look at all the individual curves, we had a couple of people relapsing after 6 weeks and starting a slide again at 12 weeks, but the vast majority of people are doing as well or better by 12 weeks than they're doing at 6 weeks. We're almost at 6 months, and I have one patient who came in with a Hamilton of 20, and at 6 weeks was a 2, and at 12 weeks was a 1, and we just got the 6 month data back, and that person's now down to a 0. So again, results not typical. I don't know if all 30 odd patients are going to turn out that way, but we certainly are seeing some people who are getting this treatment are still doing well 6 months later. We've had a couple of others who've started to slip and are talking about relapsing. So I think for most people, the durability is going to shake out. The majority will be 3 months, and some people will make it out to 6 months without requiring retreatment. So if I had to predict, we don't know, but if I had to predict, I suspect that these one-day treatments for depression are going to be a thing that you do 2 or 3 times a year.
Super cool. And then last question on this is just that 10 hours is long, right? It's longer than a workday, and it's, for the patient also quite exhausting, I'm sure. Any thought that it might also work in 8 hours as a normal workday kind of?
It's so funny you mentioned. I think I told you I was just chatting with Noah Phillip over at the VA literally just before I jumped on here, like a half an hour ago, and we were talking about this exact issue of how to get it down to a single 8-hour shift. It's relevant for a lot of places in Canada. Same thing. It's just hard to stretch the shifts out to 10 hours. So highly important to know whether you can get it down to 15 or 20 minutes. Anecdotally, I've had 1 or 2 people tell me they've tried it and it worked. There is a recent paper that you may have seen where they were able to study the mechanisms of spaced versus mass training, not in neurons, but in human embryonic kidney cells. This is the Hexcel paper from, I think is referred to in the preprint, where they were, and Hex cells are nice because they're just easy to culture, and you have to induce the LDP type mechanisms chemically but instead of looking for AMPA receptors, you look for just luciferase. So 24 hours, how brightly is the culture shining? And what they found is that if you do 4 sessions 0 minutes apart, that's no better than 1 session. But if you do 4 sessions 30 minutes apart, that's much more powerful. And that also turns out to be true for 40 sessions 20 minutes apart and 40 sessions 10 minutes apart, but not 4 sessions 20 minutes apart, 4 sessions 30 minutes apart, or 4 sessions 10 minutes apart, but not 4 sessions 0 minutes apart. So that's very preclinical stuff. But it does suggest that, once D-cycloserine is in the picture, I think it probably does behoove us to go back and re-examine our assumptions about intervals, because what's true in the absence of D-cycloserine might not be true in the presence of D-cycloserine. And so I don't think it's a complete waste of time for people to try 15-minute or 20-minute intervals, and that's also high priority. I don't know anyone who's done it yet in a study, but I certainly know a couple of people who are gearing up to give that a try. And you're absolutely right. If it can be an 8-hour session, then that really improves the scalability of TMS dramatically.
When you visited us at the center, you gave me the recommendation to buy the book Loon Shots, and I bought it, but I haven't read it yet. And I think you, in your talk, you said that your loon shot was to treat 1 billion depression patients in our lifetime. What would need to be done to achieve that?
Yeah, so it's interesting that. So, I mean, I hopefully not me personally doing it, but hopefully our community at large, are there 1 billion people to be treated for neurological and psychiatric conditions with brain stimulation? I think there are. And then, not that TMS has to do all the work, but is there a world where we could make TMS scalable enough to literally reach 1 billion people? Well, to do that, I think it's going to have to be, so if we draw a column of comparisons, compared to conventional antidepressant medications, TMS is certainly more effective now by a good margin. Side effects certainly superior by several orders of magnitude in terms of the number of people who drop out from a TMS trial versus a medication trial. Where it's losing out is cost and convenience. So, a 36-day course is not very convenient. I think a 1-day course is arguably quite convenient. And then the other piece is cost. So if TMS can be reduced to about the same cost as medications, cost per remission, then we have something to work with. If it's not the same cost per remission, then it's going to be hard to imagine how to scale it. So the loon shot really boils down to, is there any possible world where TMS hardware and protocols can be optimized in a kind of SpaceX-y fashion to the point where it costs about the same as medication per remission and has comparable convenience? And so there are a couple of things to do there. First of all, again, if we come back to chair time, one of the neat things about the 1D protocol is it's actually, the chair time is now down to just 1 hour overall. It's 3 minutes times 20. No, naturally, of course, there's some time to get people in and out of the chair, which I'll come to. But during the 1D series, there were days where three patients came in a single day, and one of them would go at 9 o'clock, one would go at 9:07, and the other would go at 9:14, and maybe a little break. So, a skilled technician can definitely get three people through the chair every half hour, and that's phenomenal for waitlist because it means a single system can treat 780 people a year, which is pretty fantastic. It also implies a lot for the costs because even in the world of business, having spoken to some TMS clinics that operate as commercial operators, they're generally pretty happy if their treatment share can generate revenue of $2,000 to $3,000 a day. And if you've got three patients, and as long as you have enough patients, and believe me, in the world of depression, hopefully we will always running out of patients is a problem we would love to have. I don't think we'll be there for a while, but so assuming you can just find three people every day to go in the chair, you don't actually have to charge very much to do that. The cost of the room is, at most $500 a day. The cost of the technician and all the other ancillaries, maybe another $500 a day. So depending on how you're set up, there's a world where the cost of treatment or cost of delivery per patient would only have to be somewhere between $500 to $1,000 for the entire course to get them there. Now they're going to have to do that about twice a year. So again, $1,000 to $2,000 a year. And the question is, what medications are already approved that cost $1,000 to $2,000 a year? Now, the very least expensive antidepressants that are out there are, substantially cheaper than that, and maybe they're $1 a day or less. But they also only get about 1/3 the number of sustained remissions as the 1D protocol. So on a cost per remission basis, if you're a systems planner, you have to get to the point where TMS is conceivably about the same cost of delivery as just putting somebody on a script. And on an individual basis per patient, it may be a bit different, but the cost per remission achieved would be, I think, fairly comparable. And at that point, it does become more a question of scaling and execution. So I think, bizarrely, there is a world where even for fairly inexpensive drugs like antidepressants, we can probably get TMS down to fairly close to the cost of medication, if not at the cost of medication. And the main way of doing that is just by increasing the throughput. So what's neat is that treatment share is being used all the time. There's just no gaps. It's being constantly treating. Interestingly, that those numbers get better with there are some simple and dumb sounding studies that could make those numbers even better. I'll give you an example. So theta-burst conventionally is 2 seconds on and 8 seconds off, which means it's about 3 minutes long. But does it have to be 8 seconds? Like, did someone specifically check all the inter-session intervals and make it, we tried 2, we tried 4, we tried 16, we tried 32, and it turned out 8 was the best? No, 8 was used at the beginning and still being used. So one of the very SpaceX-y things to do is to question all requirements and question all assumptions. So you're going back to these things and saying, are those parameters there because someone at the beginning literally went and optimized them, or is it just this is the first one that worked, and so everyone's just done the same thing ever since? And medicine in general is full of something that worked once, and so people we don't like to mess with what works for obvious reasons. So we just copy what the last guy did, and then we stuck with these sort of unoptimized protocols, like 38 minutes of treatment years later, until we go back and optimize further. So what if you could squish it down to 1 minute? What if, for example, CTBS did a comparable job to iTBS? I don't know if it will, or maybe there's a version where it's 2 seconds on, 2 seconds off or something. So it's, 1.5 minutes. But you'll notice that if you do that, you can get even more people into the chair per day. And then the cost comes down even further. So bizarre. I don't know how you'd ever get an R01 grant to just, try shorter versions of theta-burst, because it sounds like a pretty dumb project, except it massively changes the economics and scalability and cost effectiveness of TMS. So seemingly dumb, boring questions often yield tremendously large results. And so it's just a question of, can we find people who are willing to study the dumb questions rather than the interesting ones about anatomy or machine learning or functional connectivity and so on.
And I'd say that studying these questions gets much easier once you have 1 day, right? Because you could do, let's say, even 8 different protocols in 8 groups, or like you could do it more rapidly than if you'd have.
That is definitely true. So that's one of the nice things about the 1 day study is, assuming you've got enough patients. I mean, you can have 15 patients a week could go through the study. So if you've got enough infrastructure to collect all the results on them, you could do a 150 patient study in 10 weeks on on one machine. And so,
super cool.
And, if you had two other clinics working with you, you could do a 450 patient study in that. No, there's a lot of follow-ups and things that it's not just about getting the treatments, but from a pure treatment and just getting all the sessions done perspective, these things can be executed very quickly. So other optimizations to be looking at. So that's and the other one is in terms of tolerability and so on. So do you really need to go all the way up to 120%, or could you do the treatment at more tolerable levels like 60 or 70 or 80%? Because people do find that. Here's another one. Does it need to be theta burst, or could it be something like 1 hertz stimulation? There's a lot to love about 1 hertz stimulation. We don't know what the minimum number of pulses is for 1 hertz stimulation to do things. We do know that from Paul Fitzgerald's work in 2020, we do know that 1,200 pulses of 1 hertz seems to be about equivalent to 3,000 pulses of 10 hertz, for example. And Dan Bloomberg and Fidel Villa-Rodriguez up in Canada are most of the way through a trial comparing left-sided theta burst to right-sided 1 hertz to see what that does. But what's to love about 1 hertz? There's a lot to love about 1 hertz. First of all, it's extremely tolerable. Second of all, it's very safe. Far from inducing seizures, you can use 1 hertz over a seizure focus to reduce the frequency of seizures by about half. And the little known thing about it is also that the power requirements are a lot lower. So a typical big, hefty, chunky TMS machine may have a 2,000 watt power supply in there because it only has 20 milliseconds between theta burst pulses to top up that capacitor as much as it can. So it's got to be very high power, especially at high intensities. With a 1 hertz protocol, you have 1,000 milliseconds to fill up the capacitor again between to top up the capacitor again between pulses, which means it's 50 times as much. So instead of a 2,000 watt power supply, you can use you can use a 40 watt power supply. A TMS machine that only did 1 hertz could almost run off a phone charger in terms of power requirements, and it could be a lot smaller. And it would be very safe. And if you were ever trying to be in a world where you built 1 million TMS machines and put them kind of like automatic defibrillators in every airport, every pharmacy, you just put them all over the place. And how would that not cause complete chaos? Well, among other things, if there were 1 hertz machines, at least you know that it would be very hard to hurt yourself with the 1 hertz devices. And I'm not proposing that we put them in airports and all over the places. But
sure.
I'm saying this in general. If 1 hertz turns out to do well, and if 1 hertz, so that opens up some boring but really key questions. Does 1 hertz accelerate in the same way that 10 hertz and theta burst accelerates? Does D-cycloserine enhance the plasticity and the effects of 1 hertz in the same way that it affects the others? How many pulses of 1 hertz do you need to accomplish an induction? Do you need 1,800 pulses? Do you need 1,200? Is 600 enough? Or is it just 3 minutes? Could you do 180 pulses if it were on D-cycloserine? So-called boring pedestrian questions that have huge social impact depending on the outcomes. So I'm just listing off a few things on the protocol side alone that if we could find people willing to devote some resources to solving them, then we could potentially scale up TMS a lot. And I particularly on the 1 hertz question, I would much rather, if we are trying to get to 1 billion remissions from depression or put millions of devices out there, I think it would be much easier and safer if those happen to be 1 hertz machines than if they were theta burst devices. Honestly, if I sent a patient home with a bottle of amitriptyline and another patient home with a 1 hertz TMS machine, I'd be a lot more worried about the amitriptyline patient safety than the 1 hertz TMS machine safety.
Makes sense. And then Nolan did briefly mention when we talked that they burn more through TMS coils with the same protocol. Is that something you also seem to have, like that it just burns the coils down quicker if you do so much?
Let's say, so the number of pulses per patient, so the number of pulses per course in Saint, it's 1,800 pulses 10 times a day for 5 days, so 90,000 pulses of stimulation in a Saint protocol. The 1D protocol is 12,000 pulses. It's just 600 times 20 because the D-cycloserine is saving you sessions and saving you pulses and saving you work. So I don't. And if you think of a standard course of 36 sessions of original 10 hertz TMS, which is 3,000, that is also 108,000 pulses. So interestingly, I don't know if Saint actually burns through more pulses per patient than a standard 36 session, 3,000 pulse course that we would have been doing 10 years ago. But I will say that the 1D protocol is using, almost 9 times fewer pulses than that. So not very many.
So maybe not per patient, but like I was referring more to your remark that, having the chair used all the time, right? And having the coil used all the time it could just be, since we talked about cost, that like you have to buy more coils over the years.
Potentially that's it. So some coils are more replaceable than others. I depending on the manufacturer, some coils are cooled with it, and there's different cooling systems, and so if you want to keep a coil cool, there's different ways to do it. You can blow air over it, which some manufacturers do. You can circulate cooling fluid through it, which a couple of other manufacturers do, or you can fill it with a phase change material, so it just heats up very, very slowly until it's time. And then when all the phase change material melts, then it's time to go get another coil. And then there are some manufacturers that use that approach. Each one has its advantages and disadvantages, but the cooling and then in terms of like how long the coils last and how many moving parts they have and how often you have to replace them and that sort of thing. So different approaches there, but certainly for scalability, I think you do want your devices to be small and lightweight and safe. You want your coils to be small and lightweight and easy to learn. And so there are advantages to doing things like that. I think in terms of making TMS more scalable, there's a lot of skill involved in hand drawing caps. I've always been kind of curious as to why we're still hand drawing TMS caps, maybe for the first 1 or 2 patients, but at some point it probably makes sense to just get them in standardized sizes and just make lots of them and reprint them so that, if the technician's having a bad day, that if they still get done right, you just have better quality control that way. All of us who've been in TMS rooms, anyone who's taught a TMS course, it's amazing how many ways you can misuse a tape measure. It's amazing how many ways you can measure up instead of down by accident, or put one dot on one side of the tape measure and the other on the other, or misplace a 10.2 with a 9.8, or it's just very easy for whatever reason for people to screw things up when they're doing them manually.
Sure.
And so I think having standardized caps can help with that as well. And then, of course, having less cumbersome ways to position the coil is also helpful. So we really want to have better ways of assuring that the coil is in position and being able to document where it is and so on. Again, then there's various apparatus out there for doing that, and maybe we can make that a future discussion. But certainly on the hardware side, making the caps more standardized and building in quality assurance measures to make sure the coils are in the right place. And then ideally coming up with ways to just make it easier for technicians or medical staff to learn how to do TMS. Like if we could do stuff on the hardware side where anyone can learn how to do TMS proficiently and verifiably in less than an hour, then TMS scales very well. Otherwise, if it takes weeks to learn how to do TMS proficiently, and if you can't check on them, then anyone who tries to build one clinic and then scale it up to 5 clinics and 20 clinics, you then have to start driving all over the place trying to keep an eye on what the technicians are doing, whether they're doing it properly. And I think that's quite challenging to do. I think a real world example of that would be the BrightMind trial in the UK, which has been recently executed. Using neuronavigation to make sure the coils were in the right position and so on. But it is challenging to scale that out to the community. The apparatus, it's specialist apparatus. You can't just hand it to an untrained medical personnel and just say, okay, pick this up and start using it. It just tends to get, they're hard to operate. There's a lot of ways to screw them up. And there are companies out there that are trying to simplify the navigation process, and a number of companies out there that are trying to make navigation simpler and easier. And I think that general effort is going to be helpful for the scalability of TMS.
You mentioned SpaceX before, and in your talk, you also said that the best part is no part. So getting rid of things that you don't really need is another strategy to make things cheaper, I guess. I was also surprised when you said when you weren't at the Brigham to say that you don't need the chair really, or not. A normal chair can also be helpful also. So I really love how you think. What if the status quo is really needed? If you have more examples that you can share on that end, that could be great. Yeah.
Yeah, so that's just to clarify what that is. I think I was mentioning this is one of the refrains that you'll hear in some circles in engineering, and certainly at SpaceX when they're building their giant reusable rockets. The engines used to power the rockets get smaller and simpler and cheaper with each iteration. So I think at that presentation, I put up a slide that SpaceX had posted where they had their version 1 of the Raptor rocket engine for the giant stainless steel Starship rocket, and it was just this absolute labyrinth of pipes and sensors and pumps and all kinds of things. And version 2 was stripped down to a vastly simpler looking, smaller labyrinth of fewer pipes. And then version 3, there's no labyrinth at all. It's just this very slick, smooth looking thing that it looks incredibly sleek and probably much more elegantly designed on the inside, but they just learned over time how to eliminate this, how to eliminate that. And unlike with software, where there seem to always be more features added on every year, and the OS gets bigger and bigger every year, this is a version where the hardware is actually getting smaller and simpler every year. And certainly, if we're trying to scale TMS out, then it is a bit of a different mindset. One approach to TMS is say, let's add complexity and cost and see if we can get higher emission rates. And the other approach in medicine would be a little bit like, mosquito nets for malaria, which is, we could build a laser battle station to try and zap every mosquito that comes within 5 meters of the patient. Yeah. But, mosquito nets impregnated with insecticide are really cheap and they do a decent job. So, let's just make tons of those. And so I think if we are going to try to scale TMS, then there needs to be another general design approach of simple is beautiful, where you were trying to figure out, of all the various cooling systems, which one is the simplest and requires the fewest parts and the least weight. If we can get the coil down to a light enough weight, does it really need an arm, and does it really need a chair and all this sort of thing? And is there a way to get the whole thing down to a suitcase size device? And then some manufacturers make very small, compact, lightweight TMS devices that are absolutely suitable to go in a briefcase and be shipped around. And there's more than one company that does that. And devices like that I think are going to be essential as the platform to take TMS out further into the community and close the last mile. You've heard me probably in the past talk a lot about home TMS. And I would say, 5 years ago when I was talking about this, there was a real sense that, ultimately TMS had to go into people's homes. And if you could also even eliminate the technician, a lot of the cost of TMS is not driven by hardware, it's driven by people. So, sure. If TMS is costing $200 or $300 a session, the question is, well, where the heck is all that money going? And very little of it's going into the hardware. Almost all of it's going into the people. Many of whom are on the administrative side. So probably about half of that cost is going into the back office that's trying to get the pre-authorization. Sure. And of course, some of that is then going to the folks through the back office is talking to who are trying to not get the pre-authorization. So it's possible that up to 50% of the cost of a TMS session right now is just people arguing over whether to pay the other half. But if you can get TMS down to a low enough cost, then you eliminate all of that. And so that helps. Trying to get technicians out of the picture and have it done by existing personnel would save a lot. And so on that philosophy, I think there was, I was talking a lot 5 years ago about let's getting into people's homes, because then you've deleted the clinic, you've deleted the technician, if we can make it safe enough and sort of foolproof enough, then we've actually eliminated most of the cost of TMS. And then it really is just as the cost of renting a cheap machine by the day. That was true in the era of 30-day TMS and 36-day TMS. I think once TMS is down to a single day, things shift quite a lot because people are very used to coming into hospitals for day procedures. So interestingly, if you set out to build a system to do home TMS, the funny thing is that having built that system, if it turns out that system can be used in a day, then there's way less pressure to get it all the way the last mile into people's homes. It's probably okay to keep them, for the most part, in some kind of medical setting, maybe a non-specialized medical setting like a pharmacy or a primary care clinic. But certainly, if it's only a day, or if it's only an 8-hour day, to your point, most people can get a day off on the weekend or during the week to come in for a day procedure in a hospital or a clinic, and then that's not the end of the world. So I think if the one-day treatments replicate, then it takes some of the pressure off home TMS. It may no longer be as essential. And in fact, running TMS in a clinic, and having 3 or 4 people per day in the clinic could be cheaper than making a house call and treating 1 person per day in the home. So if we're trying to make it simple and scalable, then the 1 day actually may eliminate the need for the home TMS, unless the person can't move. So my brother James Downar is the director of palliative care in University of Ottawa, and they have been publishing some interesting work that 5-day non-navigated saint-like protocols are very helpful at the end of life for terminally ill patients to eliminate existential despair with really quite emotionally tears-jerking like results of people who only have a few weeks to live and are in utter despair, and then after a 5-day course of TMS are now suddenly euthymic again for the remainder of their lives, which is really, I think, one of the greatest gifts you could give somebody at that time.
Of course.
But some of these patients are too sick to move and can't be brought into the clinic. So in that setting, you'd still want to have a small portable device that a home care nurse could learn how to use and then take into the person's home and treat them in the home setting. And, rather than go to that person's home for 5 long days or 10 long days, it would be, nice if we could get it done in a single day for these folks. So those are the kind of things we want to be looking at, I think.
Super cool. Let's close up with some rapid fire questions. Feel free to answer short or long as you want. How does the future of neuromodulation look in 10 to 20 years?
Oh my goodness. So if I had to simplify it, I'd say 3 things. Number 1, far more indications. There's a lot of indications that have a great evidence base and growing evidence base. I think top of line would be Alzheimer's looks very exciting, anxiety looks very exciting, and first line depression looks very exciting as well. Potentially stroke recovery, I think, could be very exciting. These are all areas where effect sizes that are quite large have been seen, and smaller, scalable, faster TMS would really fit very nicely. So more indications. Number 2, more modalities. So neuromodulation, TMS is the overwhelming, most common one right now. But magnetic seizure therapy is on its way as a kind of interim between ECT, and I hope subconvulsive ECT may join it as well. Focus ultrasound is getting a lot of invitation. There's some new entrants that are, I think, nearing FDA approval or at FDA approval now. So that's it. And then photobiomodulation is a relatively new but potentially interesting one for its scalability. Also transcranial electrical stimulation or transcranial pulse magnetic fields, weak magnetic fields or weak electrical fields seem to be doing a lot more than you would expect. And they're tremendously scalable in the sense that, a TDCS or a TES device could be manufactured for, a few, less than the cost of 1 bottle of medication. So, if we are trying to get to 1 billion remissions, I think TMS can certainly be part of the journey, but I think some of these other modalities are even more scalable, and it'll be very interesting to see what, some of them I think have been a little neglected because the effect sizes look weak. And so I'll be interested to see what happens if we use these same modalities on more accelerated schedules with more sessions and with the enhancement of neuroplasticity. Because then, just as with TMS, potentially some of these so-called underperforming technologies could actually do really cool, exciting things if we optimize them a bit. So what do we cover? We cover new indications, new modalities, and new points of delivery, I think is the last one. So at the moment, neuromodulation is something you get in a specialist center. Democratizing it means making it suitable for use in primary care clinics, in nurses' offices, in nurse practitioner settings, and potentially even in places like pharmacies and so on. So that's, I think, where we'll see things go over the next little while.
Super cool. Any eureka moments of unexpected scientific insights that changed your thinking?
Yeah, I think honestly the most recent one is just the just being surprised at how much that D-cycloserine did for people. Mm-hmm. We have been expecting non-response to be mostly explained by off-target stimulation. So if we see a non-responder in TMS, the coil's probably not in the right place. Maybe we'll personalize it, or maybe it needs to go to orbitofrontal or dorsomedial or some other spot on the head. And what we're seeing here is that may account for some proportion of non-response, but a lot of non-response is simply insufficient plasticity. And it may be that even without having to move the coil around or the inductor around, that by addressing plasticity, that may be one of the key points. I think that insight, if it's verified, is going to be very applicable to invasive forms of stimulation as well. Like, why are we not also looking at this for DBS? Could we cut down on the number of sessions of ECT that are needed if D-cycloserine was taken? What would D-cycloserine do for magnetic seizure therapy? What would D-cycloserine do for focus ultrasound? And if you took ECT and then just turned down the dial so it wasn't quite convulsive and just was electrical stimulation, would that be enough if the person was on D-cycloserine? So I think for me, the eureka moment is that is in understanding that that neuroplasticity could turn out to be a big area for improvement that could potentially be applied across all the modalities we use for stimulating the brain.
Super cool. Have you ever pursued a research direction that turned out to be a waste of time?
I think about 80% of the things we tried were a waste of time. You have to not. I think this is really important. It is, I think, potentially dangerous to hang your entire lab or your entire funding on one hypothesis, because hypotheses do get too big to fail. And I think we've seen in certain fields in neuroscience, Alzheimer's being one of the more notorious ones, that once a hypothesis becomes a little too big to fail for these reasons, that you can end up going down the garden path. I think it's important to have a portfolio of different things we're working on. So things that we thought would be really, really useful. The very first thing we tried was dorsomedial TMS back in 2011. At the time, voxel-based morphometry was pointing more to the dorsomedial than the dorsolateral prefrontal cortex in depressions. The very first thing we tried was putting one of Mag Venture's DB80 coils over the dorsomedial prefrontal cortex in depression. And we had high hopes that this would yield an 80% remission rate, Nobel Prizes for everybody, and it would be great and all that. And none of those things happened. And dorsomedial we now know is no better than dorsolateral, at least on depression, although it may have advantages for certain comorbidities. So that did nothing whatsoever. We also, in the CARP-bind study, we really tried to come up with a rigorous way of doing twice daily stimulation versus once daily stimulation as a proof of concept for accelerated. And the CARP-bind study was a big disappointment. It seemed to indicate that there was no acceleration whatsoever and no difference in the trajectories of outcome for the once daily versus the twice daily group. We could unpack later. I think we are starting to understand some reasons for why that might be. But if we had stopped right there, and if it hadn't been for other studies like SAINT, we might have concluded that acceleration was a waste of time and that we should just stick to once daily stimulation. So, so there are, I'd say 80% of the things we've tried, and under very good reason, have not worked out. And a lot of the things, as in much of psychiatry, a lot of the things that worked out really well, we sort of stumbled across. Yeah.
Super cool. What advice would you give to young researchers interested in TMS and neuromodulation?
This is a great one. I would say talk to patients, get in front of patients and talk to them and find out what's bothering them. This applies pretty much anywhere in medicine. The world is full of researchers. If you're studying basic mechanisms, that's fine. But the world is full of researchers who are putting their brilliant minds and rigorous work into the wrong question, or questions that are not of direct translational relevance. And the world is also full of brilliant engineers building things that are building screwdrivers when it's a world of nails. So I do encourage young engineers, say, before you go out and build a hammer, make sure that people aren't using screws. Go talk to your end users. If you are a researcher, really try and get in front of patients. The patients will tell you what to work on if you listen to them and hear what they're about. All of the things that I thought were interesting to work on at the beginning of my career, like, using neuroimaging guidance and so on, we didn't get as much mileage out of those as we did by just talking to patients and finding out they were annoyed about the wait list, or finding out they were annoyed about having to come in for more than one day. So patients have usually steered us toward the right questions. And so whether you're a translational scientist or whether you're a biomedical engineer, get in front of patients, get in front of end users, talk to them. They will tell you what to work on if you listen.
Super cool. I love that advice. Is there any topic I should have asked or you would have wanted to talk about, but I didn't?
Oh my goodness. There's so,
we covered a lot.
I feel like I've already gone through, I don't know how many words this transcript is going to turn out to be, but we've covered a lot of stuff. So we're all set.
So then thank you once more so much, Jonathan, for joining. It was a big honor to talk to you and super enlightening as always. A dear colleague here, when you visited us, told me you always make us feel a bit dumb, or wasting time, because you have such great ideas, and it's really, really fantastic what you've been doing. And can't wait to see how 1D replicates and the other projects you're pursuing.
Thanks. So that's really, really kind. And if I can ask one follow-up question, maybe I'd ask you: is there any project that you're within the world of invasive brain stimulation? Is there any project that comes to mind for you at the end of this conversation? Any direction you might be thinking about?
Oh, that's a great question. So, I mean, I would love to think about what you said with D-cycloserine. Will it have effects on DBS as well, and so on? And I have to think that through more because, as we said, DBS would be chronic, right? So it's tough to take it chronically, or to even, it would be quite unspecific in a way. But potentially even also the more pulsed applications could be interesting. I mean, on that end, I think there's a big distinction between disorders such as Parkinson's that are neurodegenerative and depression, where you can really essentially bump out of for a while, be cured, right? In a way. So where I feel like for one, maybe the continuous part could make sense, but thinking about these things more, especially maybe in the world of depression, DBS for depression would be super interesting.
I mean, I if you happen to have any patients in that, the ones that come to mind for me would be if you happen to have anyone in your practice where, they've had the implantation, you look like you feel pretty good about where you've done the implantation, you feel pretty good about the technique, and yet the person's not showing a lot of clinical response. So you've tried programming it 2 or 3 times, and they're just really not getting as much of a response as you'd like. I would, if it were me, I'd be zooming in on a couple of those patients and saying, look, let's actually take the stimulator and put it on more of an intermittent pattern, more like SANT or more like 1D. And we're going to give you this medication here. And we're going to see if a lack of plasticity is standing in the way, and see if we can switch to a phasic rather than a tonic form of stimulation, but augmenting the plasticity. So if you have any patients that are stuck like that, those are the ones I'd be interested in working. And by the way, if that goes anywhere, please let me know, because I'll be curious to see.
Would certainly do,
really
yeah.
Exciting. Okay.
Thanks so much. Great.
Really great chatting with you, Andy. And again, it's always a pleasure, and I appreciate you inviting me. Thanks so much.
Thank you.